Face recognition, surveillance AI, what you should know. Have you ever wondered how your phone unlocks just by looking at your face? Or how CCTV cameras in malls and airports can identify people in seconds? That's face recognition, powered by artificial intelligence. And while it sounds convenient, it also raises serious questions about privacy, surveillance, and freedom. Welcome to Fame World Educational Hub. Today we'll break down what face recognition really is, how AI makes it powerful, where it's being used and misused, and why you should care, even if you have nothing to hide. What is face recognition? Let's start with the basics. Face recognition is a type of biometric technology that uses AI algorithms to identify or verify a person's identity using their facial features, like eyes, nose, jawline, and even skin texture. It doesn't just see your face, it maps it, measures it, and compares it with a huge database of stored faces. And with machine learning, it keeps improving, becoming faster, more accurate, and sometimes more dangerous. How does it work? Simple explanation. Here's how AI-powered face recognition works in a few steps. Detection. A camera spots a human face in a photo or video. Analysis. The software measures key features, like distance between eyes, nose width, and cheekbone shape. Encoding. These features are converted into a unique face print, a digital code. Matching. That code is compared with a database to find a match, either to verify who you are or identify who you might be. It's like a fingerprint, but digital and invisible. And thanks to deep learning, the system improves with more data. It learns to recognize you, even with a mask, glasses, or a new haircut. Where is face recognition used? Today, face recognition is everywhere, sometimes helpful, sometimes hidden. Phones, laptops, for unlocking, authorizing payments. Airports, for passport control and security checks. Police security forces, to find criminals or suspects. Retail stores, to study customer behavior. Social media, Facebook and Instagram auto-tagging faces. Attendance systems, in schools and offices. Sounds useful, right? But now comes the tricky part. Surveillance, the dark side. In many countries, face recognition is used not just for safety, but for surveillance. Governments are installing thousands of cameras in public places, linked with face recognition software that tracks people's movements in real time. This raises three big concerns. No consent. Most people don't even know they're being watched. Misuse. Protesters, journalists, or minorities can be targeted unfairly. Bias errors. Face recognition is often less accurate for women and people of color, leading to false arrests. In 2020, even IBM, Amazon, and Microsoft paused or banned their facial recognition programs because of ethical concerns. Face recognition in India. India is also adopting facial recognition rapidly. The government is working on projects like NCRB's automated facial recognition system, Aadhaar face authentication, airport smart gates with DigiYatra. While these help in efficiency and safety, experts are worried about lack of data protection laws, no public consent, and zero transparency. Imagine being watched 24/7 without ever being asked. That's the risk of mass surveillance. It feels safe until it's misused. Should you be worried? You might be thinking, I don't commit crimes, why should I worry? But remember, face recognition doesn't always work fairly. Your face print could be stored, sold, or leaked. You might be tracked across malls, roads, and metro stations without even knowing. Privacy is not about hiding. It's about having control over what you share and with whom. And as AI gets stronger, regulation becomes more important than ever. Face recognition is one of the most powerful tools AI has ever created. But with great power comes great responsibility. We can't stop the technology, but we can demand transparency, ethics, and choice. So, next time a camera looks at you, just ask yourself, who's watching and why? If you found this video informative, do like, share, and subscribe to Fame World Educational Hub, where we decode the truth behind the tech. What is machine learning? Full beginner guide in 2025. Have you ever wondered how YouTube recommends the perfect video for you? Or how Google finishes your sentences before you even type them? That's not magic. That's machine learning, a powerful part of artificial intelligence. In this beginner-friendly video from Fame World Educational Hub, we'll break down what machine learning is, how it works, where it's used in real life, and how you can start your ML journey in 2025, even if you're from a non-coding background. Simple definition. So, what exactly is machine learning? In simple words, machine learning is a way to teach machines how to learn from data, just like humans learn from experience. But instead of learning from mistakes and memory, machines learn from huge amounts of data and mathematical rules called algorithms. The more they learn, the smarter they get. How it works, beginner level. Let's simplify this with a real-life example. Imagine a baby learning to recognize a cat. You show the baby 10 pictures of cats. Eventually, the baby starts identifying them, even new ones. Now replace the baby with a machine. Give it thousands of cat pictures and tell it, this is a cat. The machine will look at patterns, fur, shape, ears, and train itself to recognize cats on its own. That's machine learning. Behind the scenes, it's doing data processing, pattern recognition, and statistical predictions. Types of machine learning. 1. Supervised learning. You train the machine using labeled data, meaning you already know the answers. Example, emails marked as spam or not spam. The machine learns from that and predicts new ones. Unsupervised learning. Here, the data is not labeled. The machine finds hidden patterns on its own. Example, grouping customers based on shopping habits. 3. Reinforcement learning. This is like teaching a dog tricks using rewards and penalties. The machine learns by doing and improving through feedback. Example, self-driving cars learning through trial and error. Where do we use ML daily? You're interacting with machine learning every single day. Netflix suggesting what to watch, Amazon showing you products, Siri or Google Assistant understanding your voice, face recognition, unlocking your phone. Even banks using ML to detect fraud. And now, ML is helping in healthcare, agriculture, space, climate change, everywhere. Do you need to be a coder? Good news. You don't need to be a programmer to start learning ML. Today, there are tools, drag-and-drop platforms, and even AI-assisted code generators. If you know how to think logically, work with data, and stay curious, you're ready to begin. Career Scope Learning Roadmap. Machine learning is one of the hottest career paths in 2025. You can become a ML engineer, data scientist, AI analyst, ML product manager, or even an AI trainer. Here's how you can start. Learn Python basics. Understand statistics data. Try platforms like Google Colab or Teachable Machine. Join free ML courses, Google, Coursera, YouTube. Build small projects, like a movie recommender or spam detector. Machine learning is not the future anymore. It's the present. And it's evolving faster than ever. Now that you understand the basics, imagine what you can build next. Want more videos on real-life ML projects, free AI tools, or career paths? Comment below and let us know. And don't forget to like, share, and subscribe to Fame World Educational Hub, where the future speaks your language. Can AI become dangerous? Elon Musk's warning explained simply. Can artificial intelligence destroy humanity? Will robots rule over us one day? Is Elon Musk just exaggerating, or is there a real threat? In this video by Fame World Educational Hub, we'll break down Elon Musk's most shocking warnings about AI and explain in simple language why he thinks AI could be dangerous, what the risks actually are, and how you should think about it in 2025 and beyond. Stay till the end, because this is not just about technology. It's about the survival of the human race. Who is Elon Musk? Why listen to him? Let's begin with a quick reality check. Why is Elon Musk's opinion on AI so important? This is the man who founded Tesla, SpaceX, Neuralink, and now xAI, an AI company. He's a tech visionary, but also one of the earliest people to warn the world about AI's risks. As early as 2014, he said, AI is our biggest existential threat. And in 2017, he added, By the time we are reactive in AI safety, it'll be too late. So no, he's not anti-AI, but he believes we are not prepared for what's coming. How can AI be dangerous? Let's understand the 3 key dangers Elon talks about. In simple terms. 1. Uncontrolled intelligence. AI systems are becoming smarter, faster than we can control them. Imagine giving a 5-year-old a rocket launcher. Now imagine giving superintelligence to a company with no rules. That's the fear, AI growing too powerful, with no human check. Job automation crisis. Millions of jobs, from drivers to writers to analysts, are being replaced by AI tools. Elon says, there will come a time when no job is needed. AI will do everything. Sounds amazing? But what about income, dignity, purpose? That's a psychological and social threat. Misuse by humans. The danger isn't just the AI, it's who uses it and how. AI can be weaponized in wars, in surveillance, in cyber attacks. A superintelligent system in the wrong hands could do irreversible damage. Real examples that support his fears. Let's look at examples that prove AI can go wrong. Facebook's AI bots once created a language of their own that humans couldn't understand. Creepy, right? In China, AI-driven facial recognition is used for mass surveillance. In the US, AI tools have shown racial bias while recommending criminal sentencing. In 2023, an AI-generated deepfake of a politician caused chaos in an election. So yes, these aren't science fiction stories. These are real-world events. AI is not always safe or fair, yet. Elon Musk's main solution: regulation. So what's Musk's solution? Government regulation. He believes AI should be treated like a nuclear weapon, monitored, licensed, and controlled at a global level. Just like we don't allow anyone to build a nuclear bomb in their garage, we shouldn't allow any company to build super intelligent AI with no oversight. In fact, in 2023, Musk and other tech leaders signed a letter asking for a pause on advanced AI development. Why? To give humans time to build laws and ethics around it. Should we panic? No, we shouldn't panic. But we also shouldn't ignore. Most AI today, like ChatGPT, Midjourney, Google Bard, is helpful and limited, but that's just narrow AI. The real risk is when we move to artificial general intelligence, an AI that can think, plan, and act like a human, or smarter. If that happens without safety checks, AI won't be evil. It will just be indifferent. It won't destroy us with hate. It may destroy us by ignoring us. What can you do as a learner? You might be thinking, I'm just a student, a user. What can I do? Here's what. Learn about AI ethics and safety. Be informed. Support responsible AI companies who value transparency and fairness. Speak up. Talk about AI risks in schools, colleges, online. And most importantly, use AI wisely. Don't just consume it blindly. Question it. So, can AI become dangerous? Yes, if built without caution and used without control. Elon Musk's warnings may sound extreme, but sometimes only extreme voices wake up the world. What do you think? Will AI save us or scare us? Comment below and don't forget to like, share, and subscribe to Fame World Educational Hub, where we decode the future, one concept at a time. Have you ever talked to ChatGPT, asked Alexa to play your favorite song, or noticed how YouTube knows exactly what you want to watch next? That's not magic. That's artificial intelligence, or simply AI. And in 2025, AI is not just the future, it's already shaping your present. Welcome to Fame World Educational Hub, and in today's beginner-friendly guide, we'll understand what AI truly is, how it works, where it's used, and why it matters more than ever before. So, what is artificial intelligence? In simple words, artificial intelligence is the ability of a machine to mimic human intelligence. That means it can think, learn, solve problems, and even make decisions, just like you and me. But wait, machines don't have brains, right? True, but AI uses something called algorithms and data to simulate thinking. It's like teaching a child. But instead of books, AI learns from data, patterns, and millions of past experiences in daily life. You're using AI right now without even realizing it. When your phone unlocks using Face ID, that's AI. When Google Maps suggests a faster route, that's AI. Netflix recommending your next favorite movie? Yep, that's AI too. From shopping apps, smartwatches, digital assistants to spam filters in Gmail, AI is already all around you. It's not science fiction anymore. It's science fact types of AI. Now let's understand the types of AI in simple terms. There are three main types. ANI, Artificial Narrow Intelligence. This is the AI we use today. It performs one specific task, like recognizing faces, translating language, or playing chess. It's fast, but it doesn't understand like a human. AGI, Artificial General Intelligence. This is a dream for now. AGI would mean a machine that can think and reason like a human across all areas. We're still far from this stage, but research is going on. ASI, Artificial Superintelligence. This is a concept of a machine that becomes smarter than all humans combined. Sounds scary? Even Elon Musk thinks so. But don't worry, it's not here yet. How does AI work? Let's keep it beginner-friendly. AI needs three main things. Data. The more data it has, the better it learns. Algorithms. These are step-by-step instructions that tell AI how to learn. Computing power. Powerful machines and cloud systems process all that data. There are many techniques in AI, like machine learning, where AI learns from data, just like experience. Deep learning, a more advanced form of learning, inspired by how our brain works. Natural language processing. This helps AI understand and respond in human language. All these combine to make AI smart, or at least smart enough to seem human. Benefits of AI. AI isn't just cool, it's also helpful. AI helps in healthcare, predicting diseases, analyzing scans, assisting surgeries. AI helps in education, personalizing learning for every student. AI boosts business, automating tasks, analyzing big data. Even in agriculture, finance, law, and space research, AI is everywhere. Challenges future. But like any powerful technology, AI also has challenges. What if it replaces jobs? What about data privacy? Can AI be biased? That's why we need ethical AI, which is transparent, fair, and used responsibly. The future of AI depends on us, how we build it, how we use it, and how we make sure it helps, not harms. So now you know what artificial intelligence is, how it works, and why it's such a big deal in 2025. This was just the beginning. In the next videos, we'll go deeper into machine learning, AI tools, and how you can start using AI in your life. If you found this video helpful, don't forget to like, share, and subscribe to Fame World Educational Hub, your one-stop place to learn the future. AI versus AGI. What's coming next in artificial intelligence? In today's fast-paced digital world, artificial intelligence is no longer just a buzzword. It's everywhere. From voice assistants answering your questions to algorithms recommending your next movie, AI is shaping our everyday experiences. But there's a bigger question looming on the horizon. What lies beyond the AI we know today? Are we truly on the verge of a new era? The era of artificial general intelligence, or AGI? To understand what's coming next, we first need to draw a line between what AI is today and what AGI aims to become. Current AI, often called narrow AI or weak AI, is designed to perform specific tasks, and it does so incredibly well. Whether it's playing chess, diagnosing diseases from X-rays, translating languages, or even creating artwork, AI today operates within clearly defined boundaries. It excels at pattern recognition, data analysis, and task automation. But it doesn't understand in the way humans do. It can't think across domains or adapt to totally new problems without retraining. AGI, on the other hand, is the dream, or perhaps the nightmare, of a machine that possesses human-like cognitive abilities. That means reasoning, learning, planning, even consciousness in some theories. AGI wouldn't just play chess. It would learn the rules of a new board game it's never seen before, understand its strategy, and possibly teach others to play. It would understand context, sarcasm, emotions, and make judgments that today's AI can't even approach. So where are we now on this path? We're in a gray area, a rapidly evolving in-between stage. Recent advances, especially in large language models, have blurred the lines between narrow AI and the early hints of general intelligence. These models can write essays, summarize long texts, generate code, compose poetry, and hold convincing conversations. But here's the catch: they still lack true comprehension. They don't know what they're saying in a human sense. They're predicting patterns based on massive amounts of data, not reasoning like a human brain. That said, the rate of progress is staggering. Just a few years ago, these abilities seemed impossible, and now we're wondering what's next. Some experts believe we're just a few major breakthroughs away from achieving AGI. Others think we're still decades out, if we ever get there at all. The journey from AI to AGI isn't just technical, it's philosophical, ethical, and social. What happens when machines start making decisions that impact human lives in profound ways? Who takes responsibility when an AGI system makes a mistake? And how do we ensure that AGI aligns with human values and doesn't develop goals of its own? There's also the question of control. Once we create a system that can improve itself, learn faster than humans, and potentially outsmart us, how do we guide its growth? Some fear that unleashing AGI without proper safeguards could be the biggest risk humanity has ever faced. Others are more optimistic, believing AGI could solve some of our greatest challenges, from climate change to disease, if developed with care. Research institutions, tech companies, and governments are all investing heavily in the race to AGI. But with great power comes great responsibility. The challenge is not just to create AGI, but to do it right, to build it safely, ethically, and transparently. Meanwhile, the line between tools and companions continues to blur. AI is becoming more personal, more integrated into how we work, learn, and live. The systems we're building today are shaping the mindset and expectations of the AGI systems we might meet tomorrow. So what's coming next? Likely, we'll see AI systems that get better at reasoning, memory, and self-reflection. We'll develop hybrid models that combine symbolic reasoning with deep learning, moving closer to how the human mind works. We might also see the rise of multimodal systems that understand text, speech, images, and video all at once. And at some point, we may cross a line where an AI system is no longer just intelligent in one area, but in many, fluidly and adaptively. Whether or not we call that AGI, the impact will be immense. It will change how we learn, how we work, how we connect with each other, and even how we define what it means to be intelligent. The road to AGI is filled with opportunity and risk, with innovation and introspection. One thing is clear: we're at the beginning of a profound transformation. Artificial intelligence, as we know it, is evolving, and the next chapter, the rise of AGI, may be closer than we think. The future won't just be about machines that can do tasks. It will be about systems that can think, reason, adapt, maybe even feel. The question is, are we ready? The rise of autonomous coding. Can AI replace developers? Imagine a world where lines of code write themselves, where software updates in real time without human intervention, and where apps are built from scratch by machines within minutes. Sounds like science fiction? Not anymore. The rise of autonomous coding is transforming the very fabric of software development, and it's raising a profound question. Can AI truly replace human developers? At the heart of this revolution is a new generation of AI models that can understand, generate, and debug code. From GitHub Copilot to OpenAI's Codex, these systems are capable of completing complex functions, suggesting optimizations, and even writing entire blocks of code based on simple prompts. What used to take teams of engineers weeks to accomplish is now being done in hours, or sometimes even minutes, by machines trained on billions of lines of open-source code. But how did we get here? It started quietly, with basic code auto-completion features. Then came AI-assisted error detection. But today we're watching AI systems write production-level code, test it, and deploy it, all with minimal human guidance. It's not just about assistance anymore. It's about autonomy. Tools are emerging that can generate APIs, design user interfaces, and even respond to real-time user feedback with updated code logic. For businesses, this shift means faster development cycles, lower costs, and the ability to scale like never before. Startups can build MVPs without hiring large development teams. Enterprises can automate routine tasks and focus their human talent on strategic innovation. The productivity boost is undeniable. But does that mean developers are on the verge of extinction? Not so fast. While AI can generate code, it doesn't truly understand context the way a human does. It doesn't feel the tension of a deadline, grasp the long-term impact of a design decision, or intuitively understand a client's unspoken needs. It lacks imagination. It doesn't dream up ideas or innovate from scratch. At best, it synthesizes what it has learned from existing patterns. Developers don't just code, they create. They collaborate, experiment, and solve complex, messy, real-world problems. AI is a powerful tool, but it still needs human supervision. It doesn't replace developers, it amplifies them. In fact, the best results today are coming from a fusion of human and machine intelligence. Developers who embrace AI are becoming more efficient, more creative, and more capable. They're offloading repetitive work and spending more time architecting brilliant solutions. It's not man versus machine, it's man with machine. But there are deeper concerns too. As AI takes on more of the coding workload, what happens to entry-level jobs? Will junior developers struggle to gain experience if machines handle the basics? Will AI-generated code be secure, ethical, and maintainable in the long run? Who will be responsible for mistakes if no human wrote the code in the first place? These are not just technical questions, they're philosophical ones. And we must confront them now. Before autonomous coding becomes the norm, education will need to evolve. We'll have to teach new developers how to collaborate with AI, not compete with it. Coding may become less about syntax and more about systems thinking, ethical decision-making, and creative problem-solving. The role of a developer will change, but it won't disappear. Looking ahead, we may see entire code bases generated from spoken language. We may see AI that not only writes code, but understands product goals, user needs, and business outcomes. The boundary between idea and execution will blur. But no matter how intelligent these systems become, they will still rely on humans to provide vision, intent, and oversight. The rise of autonomous coding is not the end of development. It's a new beginning. It's a chance to redefine what it means to be a developer. It's a call to evolve, to learn, and to lead this transformation, not fear it. So, can AI replace developers? Not entirely, but it can change the role of a developer forever. The future belongs not to the coders who resist change, but to those who adapt, who learn to wield these new tools, and who understand that at the core of every great piece of software is still a spark of human insight. AI may write the code, but people will always write the future. How quantum computing will disrupt traditional programming. Imagine a world where the most complex problems in science, medicine, and artificial intelligence can be solved in seconds. Where encryption methods that once protected global financial systems become obsolete overnight. Where the rules of programming, the very logic that built our digital age, are suddenly redefined. That world isn't science fiction, it's the promise of quantum computing. For decades, classical computers have run on bits, ones and zeros, binary logic. Every program you've ever written, every app you've ever used is built on that foundation. But quantum computers use something far stranger: qubits. Unlike bits, qubits can exist in a state of superposition, meaning they can be both 1 and 0 at the same time. And when entangled with one another, their states become linked no matter how far apart they are. These phenomena, born from the bizarre laws of quantum mechanics, give quantum computers exponential processing power. Now, here's where the disruption begins. Traditional programming is deterministic. Write the code, run the code, get a predictable result. But quantum programming introduces probabilities, parallelism, and uncertainty. It's no longer about following a straight path. It's about navigating a vast landscape of potential outcomes simultaneously. Think of it like this. If a classical computer is a flashlight shining in one direction, a quantum computer is a lantern, illuminating all paths at once. This shift demands an entirely new way of thinking. Programming languages like Python or JavaScript, while still useful for orchestrating quantum instructions, can't directly express the complex behaviors of quantum states. That's why new languages like QAlber, Qiskit, and Cirq are emerging. These aren't just tools, they're the beginning of a new programming era. And they challenge developers to understand physics, probability, and linear algebra alongside code. Debugging, too, becomes a different beast. In the quantum realm, observing a state changes it. You can't simply print a variable's value to a console. Inspecting a qubit might collapse its superposition, altering the outcome. So developers must rely on simulations, statistical predictions, and an entirely different mindset for testing and optimization. Then there's the architecture. Traditional programs execute step by step. Quantum algorithms often use quantum gates in circuits that transform the state of qubits in ways that can't be reversed. These are not loops and conditionals as we know them. They're operations that exploit quantum entanglement and interference to amplify correct answers and cancel out wrong ones. Algorithms like Shor's, which factor large numbers exponentially faster than any classical method, or Grover's, which searches unsorted databases in square root time, aren't just faster, they're revolutionary. These breakthroughs show how quantum logic can outperform traditional methods in ways we once thought impossible. And what about security? Classical cryptography relies heavily on problems that are hard for classical computers to solve. But to a sufficiently powerful quantum computer, those problems become trivial. That means RSA encryption, which underpins much of our internet security, could be broken in minutes. Entire industries, from finance to defense, must now prepare for a future where today's encryption is no longer safe. As quantum hardware scales up, from today's noisy intermediate-scale quantum devices to more stable and error-corrected systems, the pressure will mount on programmers to adapt. Universities will need to teach quantum logic alongside loops and arrays. Developers will need to rethink data structures, control flow, and even the nature of computation itself. But here's the exciting part. Quantum computing doesn't make traditional programming obsolete, it redefines its boundaries. Hybrid models are emerging, where classical and quantum processors work together. The classical side handles logic and data preparation. The quantum side tackles the parts that demand massive parallelism. Think of it as using classical tools to build the problem and quantum tools to crack it wide open. So yes, disruption is coming, but it's not destruction. It's evolution. Just as high-level languages replaced machine code and the cloud replaced local servers, quantum computing will reshape how we write software, solve problems, and think about technology. The real challenge won't be in learning new syntax or frameworks. It'll be in unlearning the assumptions that have guided programming for the last 70 years. Assumptions like determinism, binary logic, and sequential execution. Tomorrow's developers will be part physicist, part mathematician, and part coder. They'll build tools that explore the multiverse of outcomes, solve problems we can't yet define, and maybe even crack the secrets of nature itself. How ChatGPT works, the secret behind generative AI. Have you ever wondered how a chatbot like ChatGPT is able to understand and respond to your questions in real time? It might seem like magic, but there's a lot of complex science happening behind the scenes. In this script, we're diving deep into the secret behind generative AI, specifically how ChatGPT works, so you can get a clear understanding of the magic that powers these chatbots. At its core, ChatGPT is a product of a technology called generative AI, which refers to artificial intelligence systems capable of creating new content, whether that's text, images, or even music. The generative part means it doesn't just repeat information it's seen before. It can generate completely new responses based on patterns it has learned. So when you ask ChatGPT a question, it's not searching the internet for an answer. Instead, it's crafting a response from scratch, drawing on everything it has learned during its training. The magic begins with something known as a neural network. A neural network is essentially a system inspired by the human brain. It's made up of layers of interconnected neurons, each one responsible for a small part of the process. When you type something into ChatGPT, that input is processed through multiple layers of neurons. Each layer analyzes the input in different ways, detecting patterns, meanings, and relationships in the text. This deep processing helps ChatGPT understand not just the individual words, but the context and intent behind your message. Now let's talk about how ChatGPT learns all of this. To make it work, ChatGPT has been trained on an immense amount of data, including books, websites, and other written texts. This training process involves feeding the model huge amounts of text and teaching it to predict the next word in a sequence, based on the words that came before it. Over time, as it processes more and more examples, ChatGPT learns how language works. It learns grammar, sentence structure, context, and even some nuances like humor, tone, and cultural references. But here's the secret sauce. While it's trained on a vast range of texts, ChatGPT doesn't memorize the exact answers. Instead, it learns to generate responses based on probabilities. For example, when you ask a question, ChatGPT calculates the likelihood of different words following the ones you've typed in. It selects the most probable next word, then continues building the sentence word by word based on the context and previous choices. However, this process isn't as simple as just picking the next word at random. ChatGPT has been fine-tuned using reinforcement learning to make it more conversational and human-like. Reinforcement learning is a technique where the model is given feedback on how well it's doing, helping it improve over time. For instance, if ChatGPT gives an awkward or incorrect answer, it's adjusted to give better responses in the future. This allows ChatGPT to become more accurate, coherent, and responsive as it interacts with users like you. Another key aspect of how ChatGPT works is its ability to handle a wide variety of topics. Thanks to the vast range of data it's trained on, it's capable of understanding and generating responses on everything from science and technology to art, philosophy, and even pop culture. Of course, it doesn't know facts in the way a person does. It's not consciously aware or storing facts the way we might, but it's learned the patterns of how facts and concepts are typically expressed in language. This allows ChatGPT to offer helpful, contextually appropriate responses, even if it's never encountered that exact question before. But what happens when ChatGPT encounters a question it doesn't know the answer to? That's when things get interesting. ChatGPT doesn't make up answers when it doesn't know something. Instead, it gives the best response it can based on the data it's been trained on. If it's asked about a specific event that happened after its training data cut off, for example, it will usually let you know that it doesn't have the latest information. It may still try to provide a relevant or helpful response based on what it knows, but it won't invent facts. Another fascinating feature of ChatGPT is its ability to follow instructions and adapt to different conversational styles. If you ask it to write in a formal tone, it will adjust its language to match that. Ask it to be casual, and it can loosen up and keep things light. This versatility is one of the reasons ChatGPT is so engaging to interact with. It's able to adjust its behavior based on the context of the conversation and the input it receives. One thing that helps ChatGPT maintain context in a conversation is its memory. But it's important to note that this memory is session-based. That means it can remember the conversation's context while you're chatting with it. But once the session ends, it doesn't retain any information. Top 10 highest-paying computer science skills in 2025. In 2025, the landscape of technology is evolving faster than ever before, and with that comes an increasing demand for specialized computer science skills. These skills not only reflect the direction technology is heading,